Okay. Good morning or good day, everyone. I'm making this video so that uh those section that I was not able to meet will still be updated to the current lesson. No? And also for those who asked for a video on reference angle, yan, to cater their request, I will discuss reference angle. A reference angle, let us define first what a reference angle is. It is an acute angle formed by the terminal side of an angle in standard position and the x-axis. Now, as you can see, okay, I have here four reference angle. In this quadrant, or on the first quadrant, you can see this, or we have this angle theta sub 1, and its reference angle is the angle itself. Okay, whenever an angle is in, or the terminal side of an angle is in quadrant 1, therefore the reference angle is the angle itself. Now, for an angle that is in the second quadrant, no, or quadrant 2, okay, the reference angle is this small angle, this acute angle here. Okay, because it is formed by this x-axis and the terminal side of this obtuse angle. Okay, this is an obtuse angle, theta sub 2. Its reference angle is this acute angle. Okay, we can also determine the measure of the reference angle on quadrant 2 by subtracting the measure of the reference angle to 180 degrees. Later, I will show you, okay, to make it clearer. Okay, for the third quadrant, we have, okay, as you can see, I have here an angle, okay, a reflex angle, and that is theta sub 3. Its terminal side is on angle 3. Now, this or the reference angle in quadrant 3 is this acute angle here. No? Okay, and we can determine the measure of the reference angle on quadrant 3 by subtracting by subtracting 180 degrees to the measure of the angle or theta sub 3. While for the fourth quadrant angle, or the angle on the fourth quadrant, or the angle whose terminal side is on the fourth quadrant, okay, the reference angle is this small angle here, or acute angle here. It is formed by the x-axis and the terminal side of that angle. Now, this or the measure of reference angle can be determined by subtracting the measure of the angle to 360, because the whole or a whole rotation is 360, and for us to determine the measure of this acute angle, we have to subtract the measure of this angle, okay, from here up to here, okay, or from here up to here. So, okay, that is 360 minus theta sub 4. Now, let us recall some uh, basic lesson when you are in grade 9. No? If you're given sine 30, okay, its value is 1 half. Same goes with cosine 30. Also, if we're going to express 30 and 60 by region, it will be sine pi over 6. And for cosine 60 is cosine pi over 3. They are also both equal to 1 half. For our second, or let us recall the second one. No? Sine 45 is equal to cosine 45. and they are both equal to square root of 2 over 2. Okay? I suggest you have to take note of this, no? Because you will use this in solving or in finding the value of the trigonometric functions or circular functions in or using reference angle. Okay? Now, 45 degrees is also pi over 4. So sine pi over 4 and cosine pi over 4 are both equal to square root of 2 over 2. And lastly, sine 60 is equal to cosine 30 and they are both equal to square root of 3 over 2. Same goes with sine pi over 3 because 60 degrees is just pi over 3. Cosine 30 or cosine pi over 6 are both equal to square root of 3 over 2. Okay? I suggest you have to take note of this because you will use these in solving the examples later. Okay? Let us proceed to the next one. Okay, finding the value of sine theta using the reference angle. How are we going to find the value of sine theta using the reference angle? So let us have here an angle theta be a non-quadrantal angle in standard position. When I say non-quadrantal angle, those are angles between quadrantal angle. Okay, quadrantal angles are angles whose terminal side is on the one of the axis or one of the axes. For example, 90 degrees. Its terminal side is in the y-axis. 180 degrees, its terminal side is on the x-axis. And 270 degrees, its terminal side is on the y-axis. So those are quadrantal angles. And non-quadrantal angles, I will classify it as, or I will define it as angles that do not fall or that are not quadrantal, okay? To give you an example or to give you an illustration that is between 0 and 90, 90 and between 90 and 180, between 180 and 270, and between 270 and 360. So it tells us here that the value of sine theta is given by if the angle or the terminal side of the angle is on the first quadrant between 0 and 90, the value of sine theta is just sine theta. We just need to evaluate sine theta. We do not need to do anything further, you know. For the second one, if our angle is on the second quadrant, or shall I say theta is between 90 and 180, or theta is between pi over 2 and pi in radian. Okay, what we are going to do to find the value of sine theta is to subtract theta to 180. By this, we can determine the reference angle. Okay? So that will be the value of sine theta. Sine theta will be equal to sine 180 minus theta or sine pi minus theta. So let us proceed to number or the third or quadrant 3. For quadrant 3, sine theta will be equal to negative sine of the reference angle on quadrant 3, which is theta minus 180 or theta minus pi. Okay, take note that this is applicable if theta is in between 180 and 270 or theta is in between pi and 3 pi over 2. Okay, and lastly, for the fourth one, we also have here the value of sine as negative sine of the reference angle on the fourth quadrant, that is 360 minus theta. Okay, this is only applicable if theta is in between 270 and 360, or the value of sine theta is negative sine 2 pi minus theta, Take note that this is negative. Actually, these both of or these two are just the same. Okay, the only difference is uh, for the first one, I use degree, while for the second one, I use region. And this is applicable, or this is what we're going to use if theta is in region and falls between 3 pi over 2 and 2 pi. To give you an example, I have here, okay, I have here sine 150, sine 5 pi over 4, and sine 300. And we are going to use the reference angle to solve or to find the values of the following. Okay, sine 150. Okay, as we all know, 150 falls between or lies between 90 and 180. Okay, implies that 150 or the terminal side of 150 is on quadrant 2. Therefore, or then, we will use the second one. Sine theta is equal to, or the value of sine theta will be sine 180 minus theta. But let us recall the value of theta. Obviously, the value of theta here is 150. Okay, so let me replace theta, all these theta by 150. Okay, there you go. So 150 is between 90 and 180. Okay, sine 150 now is equal to sine 180 minus theta, which is 150. And subtracting these two, it will give you sine 30. And based on the slide that I have presented a while ago, sine 30 is equal to 1 half. Meaning to say, sine 150 degrees is equal to 1 half. Now let us proceed to the second example. Sine 5 pi over 4. Okay. If we're going to locate 5 pi over 4 for the theta, it falls between pi and 3 pi over 2. Okay? It is on the third quadrant. Therefore, we will use the third one. And take note that since theta is in region, we will use the region counterpart. Now, sine theta now is equal to negative sine theta minus pi. And we all know that the value of theta is 5 pi over 4. So I will replace theta by 5 pi over 4. Okay, there you go. So I have here 5 pi over 4, 5 pi over 4, 5 pi over 4. Now let us subtract 5 pi over 4 minus theta, or minus pi rather. Now, if we're going to ask how to subtract, let us have here an imaginary fraction. Okay, which is equal to 1, 4 over 4. Okay, since first 5 pi over 4 and pi are the similar fraction, okay, I have here I have here 4 as the denominator of pi. Since we have 4 as the denominator of pi, we should also have 4 as the numerator of pi. Now, subtracting 5 pi 5 pi by 4 pi, it will give you, for a while, no? Erase. Okay? Subtracting 5 pi over 4 by pi will give you pi over 4. Okay? And we all know that the value of sine pi over 4 from the previous slide is square root of 2 over 2. So, the value of sine 5 pi over 4 is negative square root of 2 over 2. Okay? Let us proceed to the third one. Sine 300. Sine 300 falls between or lies between 270 and 360. Then, we will use the fourth one, the degree counterpart. Sine theta now will be equal to negative sine 360 minus theta. But what is theta? As we all know, that is 300. So 360 minus 300 will be 60, sine 60. So we all know the value of sine 60 as square root of 3 over 2. So let us replace sine 60 by its value square root of 3 over 2. Therefore, the value of sine 300 degrees is negative square root of 3 over 2. Okay? That is all for our example for finding the value of sine theta using reference angle. Let us proceed to cosine. Now, I would like to show you at once na, no? Okay, the only difference between the slide that I previously presented, okay, to this is a while ago I used sine here. Also for this one, sine for this. I just replace sine by cosine. Second is, as you can see, a while ago the our sign is negative on the third and the fourth quadrant, 3 and 4. Now, if we're going to take a look at this, the negative value of cosine or uh, negative cosine is now on 2 and 3. Okay. While number 4 is positive. Okay. It means on the second and third quadrant, cosine is negative. Okay? That is the only difference between the sign or the value of sine theta and the value of cosine theta. No? Now, I have here the same angle, but now we have cosine. A while ago, I used degree for number 1 and number 2, for number 2, I used radian, and for number 3, I used degree. I just interchange or I just reverse, no? Now, cosine 5 pi over 6. 5 pi over 6 falls between or lies between pi over 2 and pi. Therefore, or then, cosine theta is equal to or will be equal to negative cosine pi minus theta. Okay. If we're going to ask, sir, why is it negative cosine pi minus theta? Okay, because 5 pi over 6 is between pi over 2 and pi. If I'm going to show you this one, no? Since theta is 5 pi over 6 and it is between pi over 2 and pi, we will use this one. Negative cosine pi minus theta. Okay? Now, what is theta? That is 5 pi over 6. Now, pi minus 5 pi over 6. How are we going to subtract these? Okay? Let me draw something here, no? Okay. Since we need a denominator 6, let us put a denominator 6. Since I put a denominator 6, I should also have a numerator 6. It tells us that we have to subtract 5 pi from 6 pi, and that is pi. Okay? That will be 5 or 6 pi minus 5 pi, that will be pi or 1 pi according to some, no? But it will be simply pi and the denominator will be 6. Okay? Raise. So this will be pi over 6. And we all know the value of pi over 6 is square root of 3 over 2. Okay, so the cosine 5 pi over 6 is negative square root of 3 over 2. Okay, let us proceed to the second example for cosine. Cosine 225. Since theta is in between 180 and 270, 225 is in between 180 and 270. Therefore, we will use the third one, the degree counterpart. Cosine theta is equal to negative cosine theta minus 180. But Our theta is 225. Okay? Theta was replaced by 225. 225 minus 180 is 45. So we have cosine 225 equals negative cosine 45. And cosine 45, based on the previous slide or on the first slides that I have presented, is square root of 2 over 2. So cosine 225 is equal to negative square root of 2 over 2. Okay? Let us have the last example for cosine. Cosine 5 pi over 3. Since 3 pi over, or since theta is between 3 pi over 2 and 2 pi, okay, we will use the formula, or we will use the fourth one. Cosine theta is equal to cosine 2 pi minus theta, the region counterpart, no? So theta is 5 pi over 6. So I will just replace theta here by 5 pi over 6. Okay? 5 pi over 6 or 5 pi over 3, I stand corrected. Let us subtract 5 pi over 3 from 2 pi, and that will be pi over 3. If you're going to ask me, sir, how did you do that? Okay, as I have said, let us have an imaginary, or let us add, uh, let us have here 3 over 3. Okay. Just one, no? We will multiply 1, or we must show a denominator 3. But since 3 is on the numerator, we will multiply it to 2. So it implies that it should be, or this will be 6 pi. This this will be 6 pi. 6 pi, because 3 times 2 is 6. 6 pi minus 5 pi. And that is pi. Okay? 6 pi minus 5 pi will be equal to pi. Okay? Now, we have your cosine pi over 3, and we all know that the value of cosine pi over 3 is 1/2. Okay? So cosine 5 pi over 3 equals 1/2. Okay, that is for the last example for cosine. Now let us proceed to tangent. Okay? The only difference between the first two circular functions is the sign, the sign of the value of tangent. Now, a while ago, for sine, the negative is on the third and fourth quadrant, where the value of sine is negative on the third and fourth quadrant. For cosine, we have the value of cosine is negative, or the value of cosine is negative on the second and third quadrant. While for tangent, the value of tangent is negative on the second and fourth quadrant. Okay? That is their difference. Now, I only have two examples here. Tangent 5 pi over 6 and tangent 225. So tangent 5 pi over 6, as I have said a while ago, okay, this is just the same angle that I'm pertaining to, no? 5 pi over 6. It is between pi over 2 and pi. So we will use the second one. Tangent theta is equal to negative tangent pi minus theta. What is pi? That is 5 pi over 6. And subtracting these two will give us negative tangent pi over 6. But what is tangent pi over 6? It is simply, yan, sine pi over 6. This is the y over cosine pi over 6, which is the x. But if you are going to recall, the value of sine pi over 6 is already given. And that is 1/2. And the value of cosine pi over 6 is already Also, it is already given, and that is square root of 3 over 2. Take note that it's or the tangent or the sign of the tangent on the second quadrant is negative. So we have here negative. So 1/2 divided by square root of 3 over 2. Okay. When you are in grade 4, your teacher taught you how to divide fraction. Okay. Let us take a look at the denominator. Let us get the reciprocal of the denominator, which will be 2 over square root of 3. And let us multiply it to the numerator. Doing so, we have here. This is the numerator, while the denominator is this one, no? Or the reciprocal of the denominator. And instead of dividing, we will multiply. Since 2 is present on the numerator and the denominator, we could just cancel this out. Okay? We could just we can just cancel that out. And that will be, or the result here will be negative 1 over square root of 3. But we are not done yet because we must rationalize this since radical is not allowed on the denominator. So to rationalize, we must multiply the numerator and the denominator by the denominator, which is square root of 3. Okay, multiplying square root of 3 and square root of 3, it will give you 3. And multiplying 1 by square root of 3, it will give you square root of 3. Okay? So the answer is, or the value of tangent 5 pi over 6 is negative square root of 3 over 3. How about tangent 225? Oops. Let me erase this. Yeah. Tangent 225, and as we all know that 225 falls between or lies between 180 and 270. That is why we are going to use the third one, which is tangent theta is equal to tangent theta minus 180. Or tangent theta will be equal to tangent theta minus 180. And we all know that the value of theta is 225, and 225 minus 180 is 45. Tangent 45 is equal to y over x, which is sine 45, it's y, and its x is cosine 45. Now, let us simplify sine 45 and cosine 45. Sine 45 is simply square root of 2 over 2. And cosine 45 is also square root of 2 over 2. And it is just like dividing the square root of 2 over 2 by itself. Therefore, the answer here, or the value of tangent 225, is 1. Okay? That is all for the circular functions. Now, if you want to, the challenge now is, how are you going to find the value of secant, cosecant, and cotangent? Now, the only thing that you need to do is to get the receipt for sine, or for cosecant. You just need to uh, get the reciprocal of sine that corresponds to that, no? Sine theta, or the reciprocal of sine theta is cosecant theta, or the reciprocal of cosecant theta is sine theta. And then, if there are some denominator that is in radical, you just need to rationalize. Okay? For secant, its reciprocal is, or the reciprocal of secant theta is cosine theta, and the reciprocal of cotangent theta is tangent theta. Reciprocal is just interchanging the position of the numerator and the denominator. Okay? Now, due to request, no, I will discuss these problems involving circular functions. In this problem, we are asked for the coordinates of point P that lie on the terminal side of theta. And we should also take note that point P is on the unit circle. The value or the given theta here is 107 pi over 3 and it is quite large. So for us to make it more simple, we must determine what angle coterminal to 107 pi over 3 that is between 0 and 2 pi. For our solution, we will let theta prime be an angle coterminal to theta whose measure is between 0 and 2 pi. On my discussion, on my discussion or during my discussion regarding or about coterminal angles, I use x instead of theta prime. And I was not able to give examples that involves region. Okay, so this example involves region. To determine the measure of theta prime, we have theta prime is equal to theta minus 2 pi k. Okay, instead of having 360 here, we have 2 pi. And we should take note that k should be an integer. But what is the value of k? Now, the value of k is the ceiling or the flooring function of theta over 2 pi. Before we have the value of k as theta over, or the flooring function of theta over 360. But I just replaced 360 by 2 pi. Theta is 207 pi over 3. I just replace it, no? And then, simplifying this, it will give us, okay, we will just combine the denominator. 107 over 6, the pi will be cancelled. So 107 over 6 is 17 point something. Okay? But since we are asked to round it off because of the flooring function or the greatest integer function, we have here 17. Okay? Now, if we're going to uh, insert the value of theta, which is 107 pi over 3 on our equation, that will be uh, theta prime is equal to 107 pi over 3 minus 2 pi multiplied by k, which is 17. And simplifying this, it will give us 5 pi over 3. Now, this is the angle coterminal to theta, 5 pi over 3. Now, the point on the terminal side of 107 pi over 3, which is the theta, is just the same as the point that is on the terminal side of theta prime, which is equal to 5 pi over 3. And its coordinate is cosine theta prime sine theta prime. This is just the x and this is just the y. Okay? Replacing theta and theta prime by their values, theta is just 107 pi over 3. Theta prime is just 5 pi over 3. And as I have said, theta prime is just 5 pi over 3. I just replace theta prime by 5 pi over 3. Now, if we are going to recall the previous lesson or the lesson that I have presented to you a while ago, since 5 pi over 3 is in between 3 pi over 2 and 2 pi, or shall we say, it is on the third quadrant. Therefore, this will be, or the cosine, or sorry, this is on the fourth quadrant, not on the third quadrant. Therefore, the cosine will be positive and the sine will be negative. Okay? Simplifying, okay? I will just skip some steps, no? But if we're going to simplify cosine 5 pi over 3, that will be equal to cosine pi over 3. Actually, if I'm not mistaken, I already discussed this a while ago, or this is included on one of the examples. And sine 5 pi over 3 will be negative sine pi over 3 because it is negative because y on the value of y on the fourth quadrant is negative. Okay? Now, what is cosine pi over 3? If you're going to recall the slide that I previously presented, that is 1/2. And the value of sine pi over 3 is the square root of 3 over 2. However, it is negative because it is on the fourth quadrant. So, if we have here point P on the terminal side of angle theta, whose value or and theta is 107 pi over 3, the coordinates of this point P will be 1/2 square root of 3 over 2. For our second example, we have here find the 6 trigonometric functions of the angle if the terminal side of theta in standard position passes through the point -8, 15. We should take note that x here is -8 while, while y here is 15. And the value or for us to find the value of r, we just need to use this formula. The square root of x squared plus y squared. And x squared is the square of -8, while y squared is the square of 15. And simplifying this will be 64 plus 225, and that is 289, and the square root of 289 is 17. Now, since we already know the value of x, y, and r, we can now say, or we can now determine the value of the 6 trigonometric functions. Excuse me. Okay, sine theta now will be y, which is 15, over r, which is -8. Or shall I say -15, or r is 17 rather. So this will be 15 over 17. For cosecant theta, we just need to get the reciprocal of 15 and 17. Or 15 over 17, that will be 17 over 15. Let us have cosine theta. That is just x over r. We all know that the value of x is -8, while the value of r is 17. So this will be -8 over 17. For secant theta, we have r as 17 and y as, or there is something wrong with this. Yes, it should be x, r over x. I was not able to edit this one, but this is r over x. Okay, this will be -17 over 8. Okay, now let us have, okay, let us have this. Tangent theta equals y over x. Okay, y is 15 while x is -8. So this will be 15 or -15 over 8. While this one, okay, I was not able to edit also this one. It should be r or x over y. Okay, this one is correct, but this one, yeah, I was not able to edit this. So this will be x over y, and that will be -8 over 15. Okay, the reciprocal of tangent theta. Okay, that is for the second example. And for the last example, we have here the value of cosecant theta as 13 over 12. With this, we can determine the value of sine theta. It is just the reciprocal of cosine theta. But first, let us have the solution. Cosecant theta is simply r over y. However, or with this, we can say that r is 13 and y is 12. And the reciprocal of this 13 over 12 is just the sign or the value of sine theta. Therefore, the value of sine theta is 12 over 13. Now we have the value of sine theta. All we need to do is to find the value of cosine theta. Okay, this is the value of, or this is the formula for r. However, r is given, that is 13, and y is given, that is 12. I just replace r and y by 13 and 12. So to eliminate the radical symbol here, let us square both sides. 13 squared will be 16, or sorry, 13 squared will be 169, and squaring both sides will eliminate the radical symbol. Now, by algebraic manipulation, I will subtract 169 by 144, and that will be 25. And the square root of, or for us to determine the value of x, we should take the square root of both sides. And that will be positive or negative 5. Meaning, cosine theta is, since its value is x over r, the value of cosine theta is positive or negative 5, which is 5, or which is the x, over 13, which is the value of r. Now, however, we have here a condition. It tells us here that the theta is on the fourth or on the second quadrant. And we all know that on the second quadrant, the value of cosine theta is negative. So we will just consider the negative value of cosine theta, and that is negative 5 over 13. So we now know the value of cosine theta. We now know the value of sine theta. Let us add these two, sine theta plus cosine theta, or 12 over 13 plus negative 5 over 13 will give us 7 over 13. And that is all for this video.